In the next few videos, I want to work with a different image. Let me show it to you. It's this very regular looking grid of letters and numbers. And I have the NumPy version of it here as ARR. And the first thing I want to do is I want to check, it looks like there are 3 different colors in this image, but sometimes it can look like that, and secretly there are many more colors. So here I want to verify that we're correct, that there are exactly 3 colors, and I want to show you how we can do that using NumPy. So let's look at ARR. And so if we look at ARR.shape, it's quite a bit bigger than our penguins image. It's 2000 pixels high by 2000 pixels wide. And here, as we're looking at it, this is the upper leftmost RGB triple. Okay, this is the upper rightmost RGB triple. So this whole thing is the 0th row, the top row, and so on. And so I want to know how many distinct RGB triples show up in ARR. So if we try to do np.unique, which almost does what we want, the problem is that it flattens out all of these numbers and just tells me how many unique inside numbers show up, and that's not what I want. So instead, let me call this, how about B, and say ARR.reshape -1, 3. So this is saying I want it to have 3 columns and however many rows is necessary. And each of these columns each of these rows is going to represent an RGB triple. Okay, so here is the very first RGB triple that shows up, like the upper leftmost. Here is the last one. So if we look at the picture, the upper left and the bottom right, they should be the same color. So here is upper left, here is the bottom right, and you can see they are the same color. Okay, good. And so if I check what's the shape of B, okay, well, ARR was shape 2000 by 2000 by 3. B is now shape 4 million by 3. Okay, that's 2000 times 2000, because it got sort of flattened out. It kept the RGB triples, but it sort of lost the row and column dimensions and just combined them into one long rows dimension. Okay, this dimension here. Okay, so if we try to do np.unique B, we get the exact same thing as before we did the reshaping, so that didn't help anything. But there is an argument we can give, an axis argument to np.unique. And how I always think about the axis argument is, what is the axis that we want to change? So I don't want to change this axis here, the 1 axis or the columns axis, because I want to keep these RGB triples. But what I do want to change is this rows axis. So for example, I want to remove this from the rows axis because I only want to keep one value, like one of each unique value. So I'll keep this 180, 153, 12, and then I'll remove all 5 of these that we can see. So we're changing the zeros axis. So I do axis equals 0, which is probably also the default. And let me save the result as C. And it's not totally intuitive to me why this takes some time, but always takes about 10 seconds, even though it's just going through 4 million different triples. Okay, but now it's done. And before I show you what's in C, let me show you the shape. And what I want you to notice is that this 0 dimension really did change. Okay, but the 1 dimension stayed the same. Okay, and now let's look at C. So it kept one of these 180, 153, 12s, and then it only kept one of each unique triple. So we were right that there are exactly 3 unique triples. The only other thing I want to do is I want to find out, let's see, maybe it's easier just to display it again. I want to find out, where do the colors change from this like yellowish color to this greenish color? So for that question, all I'm going to care about is the very topmost row. So let me do ARR bracket 0. That'll get me the top row. Okay, and if I were to check what's the shape of this, Can you predict what it's going to be? Okay, well, there are 2,000 pixels going across, and each has 3 channels, so it'll be 2,000 by 3. And so what is the color we're interested in? We're interested in where does it become this 12, 153, 152 color. So I can do ARR bracket 0 equals this color we're interested in. And so this is like the first pixel, but I would rather it just say false. Okay, I'd rather it just say false rather than also having this little true here for this 153 matching this 153. So how can I do that? Well, this thing here, the exact same shape as ARR bracket 0. It's the exact same 2000 by 3 shape. And I'm going to use an axis argument again, this time with the all method. I'm going to say dot all. And now I want to know what axis do I want to change. So I want to replace this triple here with just a single false because they're not all true. And so if we were working with the big grid, then I would say this was axis equals 2. But that doesn't make sense in this context because there are only 2 dimensions, the 0 dimension and the 1 dimension. So this here, this is the 1 dimension. Okay, this is like the columns dimension. So that's what we're changing. So I say axis equals 1. Okay, and if I were to check what's the shape of this, do you see what it's going to be? It's going to be just a length 1 tuple with the name 2000. Or with the value 2000 in it. Okay, great. And so let me get back to this. So I want to know where do the trues occur in this? And that's really easy to find in NumPy. So let me go ahead and save this. Maybe I'll save it here. Let me call it, how about BM for Boolean mask? And so if I do np.non0, and remember that non-zero always returns a tuple. Okay, in this case, it returns a length 1 tuple. And so all I really care about is what is the thing inside of that length 1 tuple. So I can get that with square bracket 0. And now instead of returning a tuple that is a NumPy array, now it's returning the NumPy array, like the interior NumPy array. So this number 200, that is saying that it's in column 200 that we switch to this greenish color. And what if all I care about is not like 200, 201, 202? What if all I care about is this number 200 and whatever number this is for where it switches from the yellowish color to the greenish color? How can I get that? Well, it's quite easy in NumPy to get this. So let me save this with the name INDS for indices. And so if I did X for X in indices, I'm just getting the list version of this. But I don't want to keep all of these X's. I want to keep 200, and then I want to keep whatever the next one is where it switches. So for example, here it switches, so I want to keep this 600. And why do I want to keep this 600? Because there wasn't a 599 in here. So I want to keep X if X minus 1 is not in INDS. Okay, and let's look at it again, or IMG. So this is in position 0, 200. This is in position 0, 600, 0, 1000, and so on. Okay, that's where I'll stop this video. Thank you for watching.